that's all for example 4. Now we go on to example 5. Okay, example 5. Expand square root 1 plus x over 1 minus 2x as a series in ascending powers of x up to and including the term in x squared. State the set of values of x for which the expansion is valid. Okay, this is similar to the previous question, just that okay, we have more things to expand. Okay, so let's refer to the formula. Okay, this is the formula, and this is what I want to expand. I can write it as 1 plus x to the power of half multiplied by 1 minus 2x to the power of minus half. So, okay, so I need to expand this and this. So you see that both of them starts with 1, so we can apply the formula directly. Okay, so for 1 plus x, it starts with 1 plus nx. Okay, so I will have 1 plus, in this case n is half. Okay, and x is just x, so I will have half x. Okay, and we want, okay, before we go on further, we look at the question again. We want the term up to and including the term in x squared. So this means that I need to expand until I have the term in x squared. Okay, so, okay, now we come back to the question. Okay, now we have the term 1 plus half x, so I want the term in x squared, so I go on one more step. So the next step will be n times n minus 1. So n is half, so n minus 1 will be half minus 1, which is minus half. Okay, over 2 factorial times x squared. So since we only need the term in x squared, we will stop here, but we continue to write the ellipsis symbol because the expansion is not over, it's just that we have chosen to stop here. So the next expansion will be 1 minus 2x to the power of minus half. Same thing, we start with 1 plus nx. So n is minus half in this case, but x is minus 2x in this case. Okay, so we have minus half times minus 2x plus, okay, n times n minus 1 over 2 factorial. So I will have minus half times minus 3 over 2 divided by 2 factorial times minus 2x whole thing square plus dot dot dot. Okay, so simplifying, I will have this, and then when I expand it out, okay, we will have this. Okay, so this will give you the expansion up to the term in x squared. So next part of the question, they ask you what is the set of values of x for which the expansion is valid. Okay, for this expansion to be valid, we need to look at both the set of values for this expansion and for this expansion. So for the first expansion, 1 plus x to the power half, the expansion is valid only when mod x is less than 1. Okay, and we also need to consider the other expansion. So for this 1 minus 2x, the expansion is valid only when mod of minus 2x is less than 1. Okay, because there are 2 expansions here, so we need to consider both of them, and we must make sure that the interval that we find can accommodate both of these expansions. So what do I mean by that? Okay, let's look at it. Okay, so if I expand further, okay, mod x less than 1 will simply mean that x is between minus 1 and 1. And okay, mod of negative 2x is the same as mod of 2x. Okay, and then we continue to write. We'll continue to expand what is mod of 2x. Okay, I can bring the 2 over, so I will have mod x less than half, which means that x is between minus half and half. Okay, so because of the word and, we take the intersection between these two intervals. Okay, so I will have x between minus half and half. Okay, so how do I get this? Okay, we can look at it as we draw a number line. Okay, first I have x between minus half and half. Okay, I have x between minus half and half, and the other one, x between minus 1 and 1. So I look at the intersection. So the intersection is actually the interval where x is between minus half and half. Okay, so this interval, right, would satisfy would ensure that, okay, the second expansion is valid as well as the first expansion is valid. Okay, so we take the intersection to ensure that the entire expansion will be valid. Okay, is that clear? Okay, if that is clear, we move on to example 6.